Okay, so I'm going to do the past exam, solving the past exam question, which was the last question last year for M group. Although lots of students, they answered it correctly. It's a bit of a challenge, but they did very well. So before I go through that, I would like just to mention something which I mentioned yesterday. I'll just go through it today again, because that was the problem for some of them who didn't get it right. It's the difference between, so you need to know the difference between, don't get confused or mixed between them, d squared y over dx squared and dy over dx all squared. Okay, so the difference between them, the first one, it means the second derivative. So d squared y over dx squared, it means the second derivative. So that means you derive something and you derive it again. Example, if I have y equals 5x squared, then excuse me, dy over dx, so this is the first derivative, it will be 10x, and if I do the second derivative, what is it, and d squared y over d, well, write it underneath actually. Yeah, and what is it? Yeah, and d squared y over dx squared, which is the second derivative now, it's going to be 10. Okay? If I use the same function here and do it now, if I do dy over dx, which I know now it's 10x, then dy over dx all squared means 10x all squared, which means 100x squared, because like 10 squared is 10 times 10 and x squared, so it's 100x squared. And you can see the difference in the answer. So this is only 10, yeah, while the other one is 100x squared. So it's a big difference between them. So please don't mix between them. If you have dy over dx all squared, that means you derive the things once and you just square it. If you have d squared y over dx squared, yeah, it means the second derivative. So another thing also to mention is, I'll show you now. Also, I want to show you about, right, if we have, sorry, if we say d over dx for something, yeah, that means we need to derive that, we need to differentiate that thing in that in these brackets. Okay, so if I say d over dx 5x squared, that means that means differentiate 5x squared in respect to x. Okay, so in this case I would say, okay, it is 10x. So when we have d over dx, it means differentiate that thing comes after the d over dx in respect to x. So let's say if we have d over dx for dy over dx. So this means differentiate the dy over dx in respect to x. Yeah, so it's like dy over dx, it's already the first order or the first derivative. We do d over dx for this one, it's going to be like the second derivative. So in this case, this is going to be, excuse me, d squared y over dx squared. Another way, if you want to think about it as well, maybe that will make it easy for you. If we have, it's like d over dx, it's the same thing I'm going to write. For dy over dx, it's like if you deal with it as fractions, yeah? So basically, when we multiply fraction, we multiply the tops together, the numerators together, and the denominators together. I'll just show you an example here. If I have 2 over 3 times 1 over 3, well, let's say 5 over 3, then the answer in this case is going to be 2 times 5 divided by 3 times 3, yeah, which is 10 over 9, or is 10 times 5 over 3 squared. So you can deal with it this way if that will make it easy for you to understand. So it's like multiplying the d by the d, it's d squared. So this equals d squared, d times d, it's d squared y over dx multiplied by another dx is dx squared. It's like this way. I know the notation for it, like we write it dx squared, but that's what it means really. It means dx squared, it means dx times dx. Yeah, so dx, this notation for it, it means dx times dx, which is, as I wrote it here, dx squared, if you want to think about it this way. Okay, I hope this is clear. Right, that was just an example here for multiplying fractions. Okay, now I will move to our question from the past exam question, past exam question. I'll move this picture, go away. Okay, for this question here, as you can see, we have the first term here is dy over dx all squared. It's nothing to do with this at the moment, it's fine. The second term here, yeah, we have d over dx for yx squared. So d over dx of something, that means we need to differentiate that something, okay? So we have y, x squared, two functions multiplied together. I can use the product rule for it, yeah? Product rule. Plus y multiplied by d squared y over dx squared. So again, nothing to do. They didn't ask any, there's no command here to differentiate anything. Equals d over dx for x squared. So again, there is another command here to differentiate. So d over dx to x squared for x squared. So we need to differentiate x squared. This multiplied by dy over dx. Okay, it's just this bracket multiplied by dy over dx. Plus d over dx, again, we need to differentiate what's inside this bracket, which is y multiplied by dy over dx. So this is a product rule again. Product rule. Okay. Now, okay, so now we will differentiate. I will put down this dy over dx squared as it is. So dy over dx all squared plus. Now I have d over dx as a product rule for y, as a product rule for y x squared. So in this case, we can use the product rule, which means the second times the derivative for the first plus the first times the derivative of the second, or the other way around, it doesn't matter. I mean, it's fine. So what we do now, this is going to be, I will do the first times the derivative of the second, so that will be y multiplied by 2x. The derivative of x squared is 2x, so I'll put the 2 here, so it's 2yx or 2xy, same, doesn't matter, plus the second one. Now it's the second multiplied by the derivative of the first one, so plus x squared times dy over dx. Okay, so this is, that's the pink bit here, it's the same. I just did I just differentiated. Okay, now plus y d squared y over dx squared as it is equals. Now we need to differentiate this pink one. So the derivative for x squared is 2x. So this is going to be 2x multiplied by dy over dx. Yeah, so the derivative is only 2x. I finished this. And then it is already multiplied by dy over dx, which is the green bit I shaded now. Okay, so it's 2x multiplied by dy over dx. Then plus, now we need to differentiate the y dy over dx. Again, the product rule. So the first time the derivative of the second one plus the second one times the derivative of the first one. So that will be yeah, I will do the first times the second, the derivative of the second one. So it's y, the derivative of the second one, it's already dy over dx. So the derivative for it is the second derivative. So it's going to be d squared y over dx squared plus dy over dx, now the second, which is dy over dx, multiply by the derivative of the first. So the derivative for the y is dy over dx. So plus dy over dx multiplied by dy over dx. And this, so this is the pink, where are you, pink? Yeah, so this is the pink here. No, all of it actually, the pink. Right? And I will show you this because it's dy over dx multiplied over dy by dy over dx. We can write it this way as dy over dx squared. So this is same. That's what it means. It means dy over dx squared. Okay. Now we can cancel down. Yeah, we have dy squared. We have dy over dx all squared here, and dy over dx all squared on this side. So I'll cancel it down, the pink, the last pink part, which I make it green here. And also we have, what we have? We have y d squared y over dx. Yeah, we have this here, y d squared over d squared y over dx squared, and y d squared over dx squared. So we cancel these two as well, because if you move it to the other side, they will cancel each other, plus minus. So we end up with, we'll end up with 2xy plus x squared dy over dx equals 2xy, no, sorry, 2x dy over dx. See how simple it is now. And in the question, they ask us to find y equals. So we need to, well, well, before that, now I will move the dy, I put the dy over dx in one side, like what we did in the implicit differentiation. So this is going to be x squared dy over dx minus 2x dy over dx and equals minus 2xy. I moved the 2xy to the other side and I brought 2x dy over dx to the other side there. Right, now I can take the x outside, well actually dy over dx as a common here, dy over dx common. So I would be left with x squared minus 2x here equals minus 2xy, and then dy over dx equals minus 2xy over x squared, well, x squared minus 2x. I can take x outside as a common factor from the denominator, so it's minus 2xy over x here, x minus 2, and then cancel down these x's, right? So I will get here as dy over dx equals minus 2y over x minus 2, and that's what we've been asked in the question to show. Okay, minus 2y over x minus 2. And that was what we need to find for the first part of the question. Okay, and this part of the question is asking about finding the particular solution to the differential equation dy over dx equals minus 2y over x minus 2. So because it's a differential equation, we need to do, okay, we need to do split the sides basically, and that means we will move the dx to the other side. So we multiply both sides by dx, then we will get dy equals minus 2y over x minus 2, this multiplied by dx here. If you want it this way, it will be cancelled. Right, so we have dy equals minus 2y over x minus 2 multiplied by dx. Still I have the y on the right side. I need to move it to the left to separate basically the x's, the x and the y's. So this becomes, I will, in this case now we can divide by, we can divide by either minus, divide by 2y, or you divide by y. It doesn't matter, it doesn't make a big difference. Both are correct if you want even to try it as well. So I will divide by y here. As I said, you can divide by 2y or minus 2y, all are the same at the end. So I will divide now by y, both sides. So we'll get, there's going to be 1 over y dy equals minus 2 over x minus 2 dx. So now I have the y's in one side and the x's on the other side. Right, now we can integrate both sides. So integration for both sides, as we did this yesterday, 1 over y dy is ln y. So this is going to be ln y equals the integration of minus 2 over x minus 2. It's like we can say it's minus 2, yeah, ln x minus 2, and then plus c. I'll just write it down here for you as a note. We can write this as minus 2 integration. Yeah, you can put the minus 2 outside, and the integral of 1 over x minus 2 dx. And that's why it's minus 2, the 1 outside, the minus 2 outside. And the integral of 1 over x minus 2, it becomes ln x minus 2 plus c. So this is just for you to explain, if that will help. Okay, now because I have ln y here, then I can write my constant in terms of ln. Yeah, at the end, as I said yesterday as well, because it's a constant, it doesn't make any difference. It's a constant we don't know. So we just write it down as a ln, comes another constant, another letter, to make it easy for us to solve the question. So I will change the c into ln a. Yeah.
Miss,
I'll write it as ln a.
Miss,
Fair enough. Okay, right. Now, so I changed the C now into ln A because I have ln A here in green, I shaded in green. So now what we can do, we have minus 2 ln x minus 2. This 2, we can put it as a power for the ln. So I can write this as ln y equals minus ln x minus 2 to the power minus 1. Sorry, to the power 2. To the power 2 plus ln a. So now we can look at them. We have minus ln and plus ln a. So we can deal with it as using the rules of the ln. So we can say this as in terms of 1 ln. We can write it as ln a over x minus 2 squared. That's ln y equals, yeah. So ln y equals ln a over x minus 2 squared. Because we have ln on both sides, so we can cancel down the ln's, and we end up with y equals a over x minus 2 squared. So this is the general solution. Okay, we want a particular solution where x equals, what is it? X equals 4 and y equals 4. Okay, so is it? Yeah. So to find the particular solution, so particular solution y equals 4, x equals 4. Then we just substitute the values. In this case, it's going to be 4 equals a over 4 minus 2 is 2, squared is 4. Yeah? And therefore, a equals is it x minus 2 squared? Yeah. Is x 4 or 1? Just sorry, x is a 3, not 4. Because x equals 3. So this is going to be 3 minus 2, which is minus 1, squared is 1, and therefore a will become equals 4. So this is a, and therefore you can write the general particular solution as y equals 4 over x minus 2 squared. And that's it.